My research is about a deep learning method to predict the number of people in a room. The background of this research is that the energy consumption of buildings around the world is very high. In this case, there is an effective way to mitigate these problems is let the building be equipped with an intelligent control system that can dynamically calculate the number of people in a room and thereby adjust the light, air conditioning, and other systems. In the past research, researchers install various sensors in the room, such as carbon dioxide, light, and temperature sensors. They then connected the parameters of sensors and the real number of people in the room over a period of time. And then they train some machine learning models in here. But the result of the experiments has some problems, and most experiments did not predict the number of people in the room perfectly. Deep learning is well suited for the research as a method that they can capture some complex features and predict the relationships between the targets in in order to investigate whether deep learning model can correctly learn the relationship between sensor data and number of people, how should the input parameters be set, how should the model be constructed, how does the deep learning model perform compared to machine learning, how can the system improve the real world problems. I have constructed three deep learning models in here. The three models are multi-layer perceptron, the convolutional neural network, and recurrent neural network. They are very common in deep learning. All three of them have the different structure, but all of them use the same input. A public available sensor with room count dataset. The dataset has a total of 16 columns of data that can be used as features for the input, and the final number of people roomed is used as a label for training. In here, we have three files of the model, and the first step for all the models are the same. We are going to check path if the path of the file is correct, then check there is no empty value in the data frame. And the second step is also the same. We are going to select different combinations of the data sensors as the fixtures, then input them to the model. But there's some difference in Rn because Rn needs sequence as input. So in here we set the window size and we're going to select 20 line of data as a sequence, then input to the Rn. In the next step, we define the architecture of the three models. All three models will calculate a number of people for each row of input data, but RNN will produce 20 outputs because its input is also a 20 line row of data, and then we will select the last line as our output. In the training section, all the model use Adam algorithms as the final optimizer because it can calculate the learning rate automatically, and we use the mean square error loss as a loss function to calculate the average of square errors of the actual and predicted number of people, and set up a L2 recognition to suppress the noise that large weights bring to the model, and use a mini batch technique to use a part of the data at a time to update the parameters of the model. After the model was trained, in order to verify the accuracy of the result in all aspects, I took a 5-cross validation for in the validation part for all three models, and I use confusion matrix, accuracy, precision, recall F1 score, loss, and time as the matrix to evaluate the model, and we can see the final result in here. And through the several experiments, we obtained the following graphs. Now, the opening questions can be answered. 1. Many of the correct rates are higher than 90, so the deep learning method can correctly learn the relationship between the data and the number of people in the room. Second, the temperature, lights sensors perform the best in MLP because they have the highest performance while using the fewest number of sensors. Third, compare into the traditional machine learning, the deep learning method have some problems, such as in some combinations being correct at a much higher rate than the F1 score. But deep learning has 99 accuracy and 99 F1 scores in many combinations, which machine learning can do. So I think deep learning is a better approach in predicting the number of people in a room, and the more details can be found in the dissertation. In conclusion, this experiment achieved very accurate results in estimating the number of people. And if deep learning is used to calculate the number of people, it could intelligently regulate energy use in buildings and also detect the presence or absence of people in dangerous area. But again, careful consideration needs to be given to how the data is connected and how it is combined.